What is plaintext? Is it A, the encrypted version of a message? B, the original readable message before encryption? C, the ASCII code of a character? Or D, the key used for encryption? The correct answer is B, the original readable message before encryption. Plaintext is the message or character before encryption is applied. For example, the word hello is plaintext because it is still in its original readable form. When encryption is applied, that plaintext is transformed into ciphertext. So remember, plaintext is the original readable message before encryption. What is ciphertext? Is it A, the original readable message? B, a character's ASCII code? C, the encrypted or encoded message? Or D, the encryption key? The correct answer is C, the encrypted or encoded message. Ciphertext is what we get after encryption has been applied. For example, suppose our plaintext is data. After applying our encryption method, it becomes GDWD. So, data is the plaintext, and GDWD is the ciphertext. Ciphertext is designed so that the original message is not immediately readable. To recover the original message, we need to decrypt the ciphertext. So remember, plaintext is the original message, ciphertext is the encrypted message. The ASCII code for D is 68. What happens when we apply a shift key of +3? Is it A, D becomes A, B, D becomes E, C, D becomes F, or D, D becomes G? The correct answer is D, D becomes G. Let's see why. We start with the ASCII code 68. Then we apply the shift of +3. So, 68 plus 3 equals 71. ASCII code 71 represents the letter G. Therefore, D becomes G. So remember, convert the character to its ASCII code, apply the shift, and then convert the new ASCII code back into a character. The ASCII code for D is 68. What character is produced when we apply a shift of -3? Is it A, B, C, C, or DG? The correct answer is A. Let's see how we get the answer. We start with the letter D, which has the ASCII code 68. Because our shift is -3, we subtract 3 from the ASCII value. So, 68 minus 3 equals 65. ASCII code 65 represents the letter A. Therefore, D becomes A. So remember, a negative shift moves backward through the character codes. In this example, D, 68, minus 3, 65, A. Which function converts a character into its character code? Is it ACHR, BORD, CINT, or DPrint? The correct answer is BORD. The ORD function takes a character and returns its character code. For example, let's use the letter D. When we write ORD of D, the result is 68. That is because the ASCII code for uppercase D is 68. We can do the same with other characters. For example, A gives us 65, Z gives us 90, and lowercase a gives us 97. So remember, when we want to go from a character to its code, we use ORD. In our example, D, ORD, 68. Which function converts a character code back into a character? Is it AORD, Bcode, C, CHR, or DSTR? The correct answer is CCHR. The CHR function takes a character code and converts it back into its corresponding character. For example, we start with the ASCII code 71. When we use CHR of 71, the result is the letter G. So, 71, CHR, G. We can use the same function with other ASCII codes. For example, 65 becomes A, 97 becomes lowercase a, and 48 becomes the character 0. So remember, ORD converts a character into its code, while CHR converts a code back into a character. For this question, the correct answer is CHR. The word cat is encrypted using a shift key of +3. What is the ciphertext? Is it ADBU, BFDW, CEXV, or DFDX? The correct answer is BFDW. Let's work through each character. First we have C. The ASCII code for C is 67. Add 3. 67 plus 3 equals 70. ASCII code 70 represents F. Next, A has the ASCII code 65. 65 plus 3 equals 68, which represents D. Finally, T has the ASCII code 84. 84 plus 3 equals 87. which represents W, so C becomes F, A becomes D, and T becomes W. Therefore, cat becomes FDW. The correct answer is B, FDW.